Okay, section 2.4, exponential function manipulation. We're going to start this lesson off by reviewing some properties from Algebra 1 and Algebra 2 that showed up not only in those classes, they show up in this class, they show up in future math courses as well as the SAT. So definitely one that we want to make sure that we're strong on here. So we're going to start with what's called the product property. And it says this: if you're multiplying two things that have the same base, it could be a number, it could be an x, or any other variable. But if you multiply two things that have the same base, all you have to do is add their exponents together. All right, let's contrast that with the quotient property, which says that if we're dividing like bases, we would subtract their exponents. All right, so if you're multiplying like bases, we add the exponents. If you're dividing like bases, we subtract. So a few examples of this. This would be a case where we're multiplying like bases, the base being x. And so we're going to add the exponents. So that would just give us x to the 5th. Over here where we're dividing, we're going to subtract the exponent. So it's x to the 4th divided by x to the 1st. We don't divide the exponents, we subtract them. So this is x to the 4 minus 1, or x to the 3rd. Now at the bottom, let me make this a little bit higher on the screen here. At the bottom, we're given not bases that we're multiplying. We're actually given something like the right-hand side of this. And so one thing that we do in this course that's new to this part would be new to you guys, whereas the last part was a review of Algebra 1 and Algebra 2, is we're going to start on this side, and the answer is going to finish looking like this. All right, so if we're adding exponents, we can actually make this two separate bases. The base will still be 2. So two separate bases being multiplied together. One of them gets the x, one of them gets the 3. Oh, I'll probably put x first here. So x first, and then 3. All right, so these two things are equivalent, and now we can simplify this, and we can write this as 2 to the x times 8. Or sometimes you'll see the 8 in front, so it'll be 8 times 2 to the x. But we can't multiply the 8 and the 2 because they don't have the same exponent anymore. All right, this second part here, we have 2 to the x minus 3, and so we were given this side, and we want to write it like this. And so if we're subtracting in the exponent, we can divide the bases. So we can write this as 2 to the x divided by, well, we're subtracting goes in the bottom, so 2 to the 3rd. And then from there, leave the 2 to the x alone. And we could rewrite this as 2 to the 3rd, 2 times 2 times 2 would give us 8. And again, we can't simplify this. They have different exponents. This is to the 1st, this is to the x. So we're not going to make that a 1/4 here. We're just going to leave it like this. Or equivalently, dividing by 8 is the same thing as multiplying by 1/8. So you could also write it in this form right here. All right, our next two properties, we've got the power property and the negative exponent property. The power property says that if you have an exponent that's raised to another exponent, that we can multiply our exponents. All right, so for example, if we've got x to the 3rd, all being raised to the 4th, this is really x to the 3 times 4. We're not raising 3 to the 4th, we're just doing 3 times 4, which would give us x to the 12th. Now, question down here at the bottom. Again, we're actually gonna start with this, and same thing as the last one. We're gonna work our way backwards into this. And so if we're multiplying in the exponent, we could rewrite this as 2 to the 3rd, all raised to the x. And now we can evaluate 2 to the 3rd being 8, and it's just 8 to the x. All right, the next property is our negative exponent property. And it says this: if you have some value that you're multiplying with something else, raised to a negative exponent, we actually create a fraction. And when we do that, whatever's in front goes on top. Whatever's right here is going to go in the bottom, but now the exponent's positive. So first question, again, we have a negative exponent. Whenever there's a negative exponent, we make a fraction. This part just goes into the bottom of the fraction, and now the exponent's positive. But because there was no number listed in front, we know it's a 1, and so that just goes on top, 1 over x squared. All right, so that'd be our answer to this one. The next one, so 3 times 2 to the negative x, again, you can't make that a 6. All right, We're going to get rid of the negative exponent by making it a fraction. This 2 to the negative x goes to the bottom as a 2 to the positive x. And the 3, right, that's our value of a, that just goes on top, like that. All right, the last question here. So again, this is like now the right-hand side, and we're going to write it as the left-hand side. We're just using properties. Just if I'm given this one, write it that way or vice versa. So here we want to get the x out of the bottom. So to get x out of the bottom, we have to write it in this form with a negative exponent. All right, so a is 1. You don't even have to write it, but I'll go ahead and put it here. And then we're going to multiply that with, it was 3 to the positive x. Now it's 3 to the negative x. And this is our answer, or we could get rid of the 1 because, again, multiplying by 1 doesn't do anything. All right, so that would be our answer right there. All right, lastly, the kth root. So when we're talking about different types of roots, these are actually fractional exponents. All right, so if you have a fraction in your exponent, what you're going to do is make that some type of root, a square root or a cube root or something like that, raised to the first. So whatever the denominator is, that's what type of root it becomes. So for example, if we've got 9 to the 1/2, we're going to write that as the square root of 9 to the first. Okay, or just the square root of 9, and that's going to give us 3. If we've got 64 to the 1/3, well, that's the type of root, the 3, so it's a cube root of 64. And so we have to figure out which number, if we cubed it, would give us 64. And that would be 4. 4 to the 3rd is 64, so the cube root of 64 is 4. All right, that's it for this one, guys. Stay flawless.